Hi, I'm Maria, and today I want to go through an Oxbridge Medicine mock interview scenario with you, just with a couple of questions for you to answer. First, I want to share some generic tips, so I'll just go through a couple of things that I found really useful over the years, some advice I've been given and found really important to really nail this interview experience. And then I want to go through the questions. So I would really advise you to do this in real time. Maybe get a piece of paper, and when the question appears, try and write down some of your ideas about how you would answer this question. And then the next slide would often give you a couple of hints. This is to kind of guide your thinking. And then once that's over, we'll go through the answers together. This is actually very realistic of a real interview experience because the examiners would often give you hints on what to expect, kind of what sort of direction you should be going in. And that's very useful because it's actually trying to figure out whether how you're thinking is actually suitable to this course. And that's really what they assess. So without further ado, so here are a few key tips. The first one is really, really simple. Thinking out loud. You've heard this millions and millions of times, but it is truly so important because you need to be able to just look at a picture, look at a graph, look at a scenario, and really voice your first ideas, because this is the first thing that tells them that you've got some sort of thinking process going on. And if you get something wrong, they'll correct you, they'll guide you in the right direction. If you don't think out loud and you don't really know what to say, they don't really know how to direct you in the right place because you haven't said anything. And this is one of the most important things, and people do really not listen to this and get this quite wrong. The next one is kind of building on that. So you obviously will start with simple facts. You know so much because of biology A level, chemistry A level, and it serves as a brilliant foundation for these scenarios. And really, if you start with that, if you start with something you know and then build on the hints and kind of logically try and associate some things, even if you do it in a not very sure way, I'm not quite sure, but I think maybe this would help. It really shows them that you're trying to connect the dots. And then the last one is probably most important, because the real reason you're being interviewed, whether in person or online, is because these examiners are likely to be your supervisors in the future, and they really want to see whether you're teachable, whether you are someone who they can put into a room and guide you through your learning, like through the whole medicine course. So realistically, they want to see whether them giving you feedback actually changes the way you think, changes the direction in which you go into, because this is what's important to them. So often they will ask you quite hard questions at the end, something you definitely won't know the answer to, but they'll give you the right information for you to deduce something. And acting on this feedback, acting on the things they tell you, is probably one of the most important things. So based on that, let's go into our first scenario. Let's read this first. So respiratory distress syndrome, RDS, is a neonatal condition commonly manifesting as acute shortness of breath, grunting, and cyanosis. What might be the possible causes of this condition? So here I would encourage you to pause for a second, pause the video, and try and jot down some of the things that you might come up with answering this question. Okay, so we're going to come up with a couple of hints. So the hints here would be thinking about the maturity of the respiratory system. So this is a neonatal condition. So let's think about how mature is the system when a child is born? Why would this occur? And then let's think about the key components of the gaseous exchange surfaces. So something that's actually useful to the exchange of gases. What can go wrong here? Once again, just pause and maybe change some of the ideas that you had or write something new. Okay, let's go through the answer. So the first hint I gave you was maturity of the respiratory system. And really, I only mentioned that because it's very important to note here that a lot of conditions and neonatal conditions arise because of premature birth. Premature birth is a major risk factor for a number of different conditions, whether it's congenital abnormalities, circulation, breathing, all these very important and really lethal conditions. So if you mention that, it really shows that you've got an understanding of what's actually most prevalent. It's kind of the most important factor, but it's also not very hard to get. They might even, once they give you a maturity hint, you can kind of be thinking, okay, what can go wrong here? Well, a child can be premature. And then really relating it back to the actual pathology of the condition, you'll be thinking about the gaseous exchange surfaces, so the respiratory system. And you really can go into kind of, oh, how are the lungs structured? They're probably structured the same in the baby as they are in the adult, and they have to develop accordingly. You know, you've done breathing and circulation in biology A level. But the key surface here is alveoli, so you will be mainly talking about them and the importance of surfactant. However, you might not mention surfactant at all. In fact, you don't have to mention surfactant to move on to the next bit of the question that we'll be talking about later. If you don't mention this, the examiner will talk about what sort of molecule are we thinking about here. And if you don't get it, they'll still give you the surfactant, because the next questions will be based on surfactant. But that's not actually the main thing. The main thing is kind of, we have a baby here, so we need to think about the transition from the intrauterine environment, a very safe environment where the child receives oxygen from the maternal circulation through the umbilical cord, into an extrauterine environment where they have to take in atmospheric air. And what does that require? Well, that requires lung expansion. A lot of things can go wrong there because the lungs have to be fully developed. And kind of linking this back together, you're talking about the prematurity of the respiratory system, premature birth, and the role of surfactant. The next thing is quite, it's not that important to link it back to the actual symptoms, but it is important clinically. So if you don't know where to start with the maturity, with the actual, structure of the lungs, you're having mind blank, just think about, what do I have here? Acute shortness of breath, grunting and cyanosis. Shortness of breath. Why are they short of breath? Because they're not getting enough oxygen. That is hypoxia. Even if you start with that, you can think backwards and actually get to the same answers that you see at the top here. So just a hint, sometimes the answer is partially in the question. Okay, question number 2. It often happens in an interview where the next questions are they get progressively harder and they build on the previous material. Obviously, there is no error carried forward situation, so really they will just give you an answer to the previous question if they want to see how you think about something different and you get quite stuck. So here it's going to be about surfactant now because they've given you the answer. So looking at the surfactant molecule, how can the structure explain its role in human respiration? So once again, just pause the video and have a think. So a couple of hints. First, let's think about the polarity of the molecule. What do you see here? Can you note any differences between the end and the start, or one side and the other? And how does this relate to the gas exchange interface? What are we trying to fix here? What is the role that you will be thinking about? Let's go through the answer. So firstly, I was talking about polarity. What do I mean by that? Well, really, you can have a look at the molecule and look at the charges here. You don't have to think, oh, this is polar, this is nonpolar, this is hydrophilic, this is hydrophobic. Your mind might be blank, but really you just look at the molecule and you think out loud. You say, okay, I can see that this bit is charged, I can see that this bit is not charged. How does that relate? Even if you say that out loud, you say, I wonder whether this can interact with some things that this cannot. The examiner will know that you're thinking in the right direction and they will encourage you. So in this case, it's a hydrophobic tail and a hydrophilic head. And obviously they can interact with different environments. You might know about this from the lipid bilayer structure that you've studied in biology A level. Even if you haven't, you've probably heard of the bilayer anyway. So it means that the molecule is amphipathic. And what about the gas exchange interface? Why is this important? Well, we know that the alveoli are often coated in tissue fluid, and then the actual air that's being breathed in is air. So you create this interface that leads to kind of surface tension being created. You can see in the picture here, it's kind of water molecules all tightly interacting with each other. And really what surfactant can do is interact with different parts of it. So it can disrupt hydrogen bonding between the water molecules, and the hydrophilic parts, so the phosphate and the choline, but that's not really that relevant to actually knowing this. You don't have to know this. It's just you need to think about it, how it's hydrophilic, so it can interact with water, whereas the hydrophobic bits can interact with the air, which basically means that it's perfect for this air-water interface. So relating this to functions of the surfactant, it reduces the surface tension that's created, which basically reduces the work required for breathing. And linking this back to the baby that's struggling to breathe, this really makes a lot of sense. You know, the child needs less work, it requires less work to breathe. And this is what really helps it, which is why, you know, lacking surfactant is a real cause, is the real reason why the symptoms present as they do. Kind of the next leading question would then be like, okay, so what is the other function of surfactant? Is there anything else that it does? And you might already know that there are lots of alveoli in the lungs and they're all different sizes. So how does this actually work? And this leads us to the next question, question 3. Why is surfactant essential for coexistence of alveoli of different sizes? So once again, pause and have a think. I'll give you another hint here. So they might give you an equation that you might not have heard of, but the key thing is really, it's not likely to be very hard. It just means that you need to think slightly outside the box and think about the variables that you know and those that you don't know, and how you can apply that to the question you're given. So in this case, this is Laplace's law. Think about, what does T mean? What does R mean? You know, R, very straightforward, radius. So have a think about that. And think about the arrangement of surfactant and how can this really work in different alveoli with different radii. Great, let's go through the answer. So, the first hint I've given you was Laplace's law. Laplace's law, 2t over r. Really, if you think about it, it's not that difficult of an equation. It has T, you can assume it's tension, and R, you probably know from all your maths, and bio and whatever else, that it's radius. So if you have two alveoli, I would suggest you kind of draw this out really, and think about the different radius, and how in the smaller ones you have R, in the bigger ones you can say it's 2R. How would the outcome of that change if you have T over R and T over 2R? Well, you can immediately see that the pressure, if you divide by a bigger number, say you divide 8 by 4 as opposed to 8 by 2, well, the pressure will actually go down in the bigger alveoli, which means that the air would go on the path of the least resistance, which basically means all the air would transition to the big alveoli, and the smaller ones could collapse. This is an idea of surface tension, where the surface tension is actually greater in small alveoli if only tissue fluid coated them. This would not work at all, because realistically we would have very few differences in kind of alveoli, and it just doesn't work physiologically, which is where the surfactant comes in, because the arrangement of surfactant appears to be area dependent. And at the very end of the last slide, I kind of put up this picture and I kind of wanted you to think a little bit about what that could mean. And it really means that in small alveoli, the different layers could combine to form a sort of bilayer, which basically means that the density is high in small alveoli. And because of that, there is a proportionate effect on reducing the surface tension, which equals out the pressure in all of them. And it really means that since surface tension is decreased proportionately, air can now go into the smaller ones and the larger ones equally. And this is one of the other roles of surfactant that people really forget, and they're not really taught before university. But this is really quite important. And it could bring in a little bit of physics. You know, they could think about, they could spin off and show you a graph, show you, you know, maybe symptoms and signs and all sorts of things. So you kind of have to be prepared to think on your feet, because you might not know everything they give you. In fact, you wouldn't know everything they give you. They will give you some medical school material that's actually accessible with the knowledge that you've got, but you might not have the answer. They actually just want to see how you think and how you get to the right answer with the right hints and with encouragement. So, this is kind of all I have for today. So hopefully it was helpful going through a scenario like this. Stay tuned for more.